Hey guys, this is video 4.1. Today I'm going to give you a refresher on types of bonds. So let's go ahead and get started. The objectives for this video is really to explain the octet rule. Remember, it deals with valence electrons. You need to be able to identify the properties of ionic, covalent, and metallic bonds and explain bonds in terms of electrons. The octet rule review. So atoms are bonded together by sharing or transferring electrons. If you remember that, they want to reach a stable level and they want 8 valence electrons. And when they have that, they're stable. These are not going to be, they're not going to explode. Helium, you can't catch it on fire if you wanted to. It's because it has a stable outer shell. It has a full shell of valence electrons. And I want you to remember that when bonds form, energy is released. So this is going to be maybe an exothermic reaction. It's going to show off energy, whereas bonds are broken, energy is going to be absorbed. So the first type I want to talk about is ionic bonds, and it's where they're transferring. They're not sharing. There's somebody is giving up an electron and giving it to another element. And probably the most common used example of that is table salt, sodium chloride, where the sodium, the cation, it becomes a cation when it gives one of its electrons to the chlorine. As you can kind of see right here, the sodium is giving its electron. That is going to cause the chlorine to become negatively charged and to become an anion. These have a high melting point and boiling point. We could take table salt and try to boil it, and we will not be able to get it hot enough, at least at a conventional stove at home. You won't be able to melt down an ionic bond. Most are hard, and they are crystalline in shape. Ionic bond examples. So like I said, table salt is probably the most commonly used example, but there's a lot of different types of salts in chemistry that we use. They're all hard. They're solid crystals. Like I said, high melting point. And the liquid phase, if you can get down to a liquid phase, it will conduct electricity. And it has to do with there being a cation and an anion being attracted to each other from those different forces. So the next type of bond is a metallic bond, and it only deals with metals. So you will not have any gases or nonmetals doing this. So it has to be a metal. Metals lose their electron and they form a sea of electrons. And you can see right here, there's just electrons just moving all about. So this electron over here might move over here. Metals are insoluble in water, so you won't be able to dissolve them. And they're always able to conduct heat and electricity due to mobile electrons. They're malleable, which means we can be able to flatten them out like aluminum foil and make sheets of metal. And they're also ductile. It's being able to thread them together and create wires, such as copper wire, which is used in most electronics. Metallic bond examples. Here's an example of copper wire. It's hard. It has a high melting point. It's not going to boil. It's malleable. It's ductile. It's a conductor, so it's good at sending those electrons across each other, and that's what allows us to use them for electrical purposes. And we cannot dissolve it. We will not be able to dissolve copper. So if we look here, there's two different types of copper. There's copper 1 and copper 2, and it has to do with the type of charge that's present on that type of copper. Here, if you notice that copper 2 has twice as many electrons because it has a positive 2 charge, whereas copper 1 is only going to have 1 electron for each positive charge here to balance it out so that it reaches its octet. Our last one we're going to talk about is covalent bonds, and these are non-metals only. So if you look at the top right area of the periodic table, those are our non-metals, and they're going to be forming covalent bonds. And they're sharing electrons. They have a low melting point and low boiling point. They never conduct heat or electricity, and they're a soft solid or they're a gas. A while ago I mentioned that we cannot melt down table salt, at least not a conventional stove at home, but we can melt down sugar. Sugar is made up of non-metals. It's made up of carbon and hydrogen and oxygen in this covalent bond, and we're able to melt it down and create syrup with it. Okay, so let's keep looking at what type of bonds we have here. Our next one is potassium and bromine, and it's a metal and a non-metal, so it's also going to be an ionic bond. Our next one is sulfur and chlorine, and those are two non-metals. So two non-metals is going to be a covalent bond. Our next one is iodine and sulfur, and there we have a non-metal and a non-metal, so it's going to be covalent, just like the one on top. The next one is lithium and magnesium, and this is a metal and a metal, so it's going to be considered a metallic bond. If we have barium and sulfur, it's going to be metal and a non-metal, and it's going to be an ionic bond. So hopefully I re-explained the octet rule for you. You'll know the properties of ionic, covalent, and metallic bonds and be able to explain bonds in terms of electrons.